Today, we're here to look at the Mushkin Reactor 512GB SATA SSD. So this thing is neat, not because it's an SSD, but because Mushkin's doing something interesting with the technology. First of all, this uses an interesting controller. The controller on this thing is the Silicon Motion SM.2 46EN. Now this is basically a super low cost. Mushkin has done everything imaginable to lower the cost of production on this particular component. So we're going to take it apart and we're going to look at it on the inside. Micron is the company that's responsible for the flash, but Mushkin is doing something interesting here. So Micron is selling the flash wafers to Mushkin, and then Mushkin is packaging them. And so when they get the flash wafers, you know, different a wafer would have the silicon for, you know, dozens, perhaps hundreds of flash chips. This is a 16 nanometer flash process, and the deal with this is that Mushkin then gets to do the packaging. And so the really high-end flash parts that are on those wafers are the ones that pass validation. Those will go into drives like these. The ones that maybe don't do so well would head for flash drives and would head for other stuff that uses flash memory. So if you're going to use flash memory and you're going to, you know, say like you're going to make a toy or you're going to make something that just needs a little bit of flash memory, then like the bottom of the barrel flash will go there. But by buying the flash in wafer format from Micron, Mushkin can do their own packaging, and that's a cost savings there. And Mushkin can sort of pick and choose which flash is high quality and which flash is maybe a little questionable and will go into other devices. And so that's how they're able to get the flash memory cost here really low. Not to mention with the 16 nanometer device, I mean, we're talking about serious shrinkage in terms of the real estate that is on the silicon wafer. And so that's what they use here. Now the Silicon Motion controller, I think it's a quad channel. And so with the 512 gigabyte and the 1 terabyte, yes, this is available in 1 terabyte, SSDs, they're basically going to be the same speed because it's 4 channel. There is a 256 gig version of this, but it's going to be a little bit slower because of the arrangement of the chips. Basically, there's 2 dies in one package on the 1 terabyte SSD, and there's one silicon die in the package on the 512 gigabyte SSD. This also has Samsung RAM, which is interesting, I thought. Now, in terms of benchmarking, because this is such a low cost part, I really thought that the benchmarks would just be kind of so-so, but actually for the price point for what this is, the benchmarks in this are really, really incredible. The only workload that really had any problems was massively multi-threaded workloads like you would see in a server type environment, even like a small business workload. And it really kind of suffered for that. The algorithm, the firmware that's provided by Silicon Motion, Mushkin doesn't really have to do anything with the firmware. So as far as I know, until somebody corrects me, the firmware situation with Silicon Motion is that Silicon Motion makes the firmware and then just leaves it up to the manufacturers to customize if they want. But most don't, because they don't have the R&D budget, because it's a low-cost product. Not to say that Mushkin hasn't done a lot of work as far as validation and testing goes. It's just that they're not gonna veer too far off the path with the controller firmware in order to make sure that it, you know, runs properly. But they are going to do the validation testing and things like that to make sure that the firmware that they've been given works. They're just not going to modify it a whole bunch, because that opens up a whole Pandora's box of, well, did the changes cause the problem, or is it a problem with the original firmware? At least as far as I know. In terms of performance, though, I was sort of surprised. You know, the advertised speed on this is 560 megabytes per second read and about 460 megabytes per second write. That's basically on the mark. In our benchmarks, we were seeing about 520, 530 megabytes per second on average across the board, and the writes were about 410, 415, something like that. Same deal with IOPS. You know, random read IOPS is up to 71,000 IOPS. I think the highest that we saw was about 69,000 IOPS, but that's spitting distance. That's all right. The other cool thing is 16 nanometer, all kinds of experimental technology, 3-year warranty. So 3-year warranty, which is really good for flash, really good for experimental technology. One other interesting thing that they did to lower the cost is that the SATA connector is actually part of the PCB. This is the first time that I've seen this, where the PCB actually passes through the little guide plastic. And so instead of being like soldered on, the SATA connector and the power connector are actually part of the printed circuit board. This is the first time that I've seen that. And that's got to be a pretty good, you know, 10, 15 cent, 20 cent maybe cost savings off the bill of material of this thing. It is a 2.5-inch SSD. It's 7 millimeters tall, so it works in a notebook. This particular configuration also is very, very power frugal. So if you've got like one of the old MacBooks that takes 2.5-inch SSDs, or an old notebook that takes SSDs, the price point for this and the performance of this, and the fact that it doesn't use hardly any power, because 16 nanometer and new technology, this is the upgrade for you. This is actually really impressive, what they've been able to do with this. The particular type of Micron flash memory is a Micron 16 nanometer L95B. So I'm definitely going to give this our seal of approval. Now, if you are going to buy one of these, or you have bought one of these, I would suggest that you do some burn-in testing with one of these for a while. Copy 20, 30, 40 gigabytes of data to it, delete it, and then copy another 20, 30, 40 gigabytes of data to it. If this thing dies or has problems, chances are it's going to die or have problems within the first week or two of usage. So I would think that, just running through and dumping a whole bunch of data to it, maybe doing some tests under Linux would be good. I was also delightfully surprised that when I used this under Linux, the reported smart variables basically all made sense. I didn't have time to do a full, okay, do all of the variables make sense? But sometimes when you're using the smart monitoring tools under Linux with error corrected sectors and other data that's reported, it's not really clear exactly what the drive is reporting. But under Linux, drive worked fine, trim worked fine. So I was glad to see that trim and other support under Linux seem to work fine. Now, I am using the very latest bleeding edge kernel. I didn't try one of the old kernels, so I don't know if it's just made it onto a device list or just supporting the trim standard was fine there. I know that Samsung drives, for example, have to have some workarounds. I was a little bit worried about that since this is a new Silicon Motion controller, but trim seemed to be working fine. Of course, in order to make absolutely sure, I would have to fill the drive with 512 gigabytes of crap, and then and then delete some stuff and see what happens and see if the performance recovers. I did not have a chance to do that, so if I'm wrong about that, somebody let me know. All in all, though, for the money, this is a really solid product. I'll actually probably pick up a couple of these for my home computer. I've still got some spinning rust in my home computer. The main drive in my home machine is an SSD, but it's not very big. And so, I've still got some spinning rust in there for games and crap like that. And at this price point for 1 terabyte, screw it. I'll just get a couple of those and be done. I don't care, whatever. So this has actually been a lot of fun. There's also a M.2 version of this. It's M.2 SATA. So if you're rocking the Asus Sabertooth X99, where it's got the PCI Express only M.2s, that won't work for you. But it is a SATA M.2, and we're going to take a look at that next. Now, the Mushkin Atlas is a really neat piece of hardware because it uses a SandForce controller and it's an M.2 form factor. So you've got to make sure that if you're going to get one of these, that your M.2 slots support a SATA mode of operation. The Asus X99 Sabertooth, for example, does not support that. The full benchmarks for this are on the Tech Syndicate site, but it really performed like any other SandForce SSD out there. The amazing thing is that they've crammed it into an M.2 form factor. The fact that this is a SandForce controller and a SATA interface for M.2, for me, SATA in the M.2 form factor doesn't make a lot of sense. M.2 is something that you do for performance, but if you've got an ITX system or a portable system or something where you just like the sexiness of M.2 and having it out of the way, then this is a really good M.2 option that is a lower cost option if your motherboard can deal with SATA through your M.2 connection. But if you can deal with a SATA drive, then I would really suggest that you look at the Mushkin Reactor, which uses the Silicon Motion controller. It's a little bit bigger because it's a 2.5-inch drive. So that's something to consider. Be sure to check out the benchmarks at TechSyndicate.com. I'm Wendell, I'm signing off, and I'll see you later.